Hi everybody, Jason McMillan here with Keep Calm and Train Your Rookie. We're going to talk about hydraulics. A quick preface here, what we're doing right now is unique to my department, our nozzles, and the particular manufacturer of hose that we have. Also, firefighter Sarah is going to be undertaking a certification program we have here in the state of Illinois called Fire Apparatus Engineer. You're going to learn a lot of the physics. They're going to have to learn all of the equations as well as the field application and problem solving of hydraulics as it relates to pumping fire engines on the fire ground. So what we did is we did a little experiment to talk about friction loss and how that changes in relation to the gallons per minute you're pushing out the nozzle. So come on in here and have a look at the nozzle. This is a select gallonage nozzle. At 100 psi discharge pressure here at the nozzle, we can select 95, 125, 150, or 200. That is for us to choose. All as usual, if we're pulling a line on a fire, we usually have the default of 200. During salvage and overhaul periods to assist with salvage and still be able to do overhaul, we oftentimes will neck it down to 95. That's where we started. Look back behind us back here to the pump. We have 100 feet of our 1 3/4 attack line. This is the attack line that we have across our fleet. Its friction loss might be different from yours. This is a little bit more expensive hose. Not the most expensive, but it's the top end. Our most expensive hose that we have is in our lightweight attack hose on our high-rise bundles. It has an even lower friction loss than what we have on our first-in pumpers. So real quick, here's what we did. We started out at 95 GPMs. Whenever we matched the flow meter that we have here, when we're getting 95 gallons per minute that matched the nozzle, our pump discharge pressure was 110 psi, which gives us a friction loss of 10 psi per 100. Then we shut down and restarted. We set the nozzle to 150 gallons per minute. When the flow meter said that we had 150 gallons per minute coming out of the nozzle, we rechecked our pump discharge pressure, and we got 125, which gives us a friction loss of 25 GPMs. Or, I'm sorry, 25 PSI per 100. Now, we added another 50. So here we went, it only took an extra 15 PSI to gain 55 gallons per minute. What we noticed is when we made the leap for the other 50, from 150 to 200, it jumped up to 45 PSI per 100. It's not proportional. We need to understand that our friction loss is dependent on the flow coming out. The more water molecules I try to get out of the same length of hose, the harder I have to push. So if we look in the numbers here, from here it was a 15 PSI differential to gain an extra 55 gallons per minute. But I needed another 20 to make the next leap. We went from 15 to 20. The more we try to push out the end, it goes up disproportionately. It's not a flat angle, it's actually a sharp curve. What you're going to find is most nozzle manufacturers with 100 psi fog nozzle for 1 3/4 line, they give it the rated flow at a maximum of about 200. Okay, and the most you can usually get out of a practical bit is 200 gallons per minute. At the longest length of 1 3/4, it's about 300 feet. What happens is you run out of pump. If you do the math out, eventually you're exceeding 250 psi at the pump discharge pressure. Remember, we only test our hose to 250. Hope you've enjoyed this little hydraulic tidbit. Thanks for watching. Please like the page, share the video, and leave us comments.